are again with a new topic. Continuing with the previous week, basically on Tuesday we have our coding lectures by 360DigiTMG, right? So we were talking about different models. Basically, we're showing you how to make a particular model, how to deploy the model from end to end. Now, what we have done till now is we have started talking about business understanding, and we talked about cleaning the data, right? We talked about how to load the file, we talked about how to clean the data, and also how to make pipelines, right? And after that, we did EDA, exploratory data analysis, of course. We cleaned the data, and after cleaning the data, we made the model. And once we made the model, we went for hyperparameter tuning. So today, we will be talking about basically the art of deployment. And this lecture will go for 2 weeks. So as we discussed, we talked about business understanding and info, everything like that. And we visualize the numerical columns, we visualize the categorical columns we had. We talked about box plot, right? Now we talked about outliers and how to treat outliers using Winsorizer, right? We saw standard scaling and column transformer, simple imputer, saw the pipeline, right? All those things, X-train, X-test, we did it all, right? We saw what's the X-train value, what's the X-test value, actually. And after that, we talked about model building and evaluation. So first of all, what we did, we made a function. We made a function using which we can evaluate any model. So DEF, train and evaluate we did. After that, we talked about different models. We took three models, we initialized three models, and then tried to fit that here, logistic regression we tried. Three models that we are trying are logistic regression, decision tree classifier, and random forest classifier. Right. After this, we got the efficiency, right? So we talked about once we got the efficiency, accuracy, model precision, recall, F1 score, all these things. So we constructed a data frame and stored our output for all three models and displayed it in tabular format like this. After that, we went for hyperparameter tuning. We saw we need to see how do we do auto ML. We'll be talking about deployment, monitoring, and maintenance. Right. So hyperparameter tuning we talked about, and also we talked about auto ADA. Right. So we made three models. Of course, we had to give its optimal. We made three models before this, and we defined the hyperparameter grid for each and every model. And then we defined a function called perform grid search. Using grid search CV, of course, grid search CV, we do cross validation, we call it. We do when our data is overfitting, right? After that, we perform grid search for every model and then evaluated the best model. And when we evaluated that, we tuned result, we saw this result, we made a data frame again, and then we saw result. We saw that random forest has increased its efficiency like anything, because before this it was 0.855 and decision tree was 0.8185 in accuracy. Here decision tree is 0.8624 and tuned random forest is 0.8651. This is very clear. Using hyperparameter tuning, we increase the accuracy, precision, recall, and F1 score of tuned random forest. After that, we performed auto EDA. Auto EDA using two libraries we saw, SweetWiz and Detail. Last time we saw how the report for SweetWiz looks like this, where you can explore each and every column, if it's positive kurtosis, negative kurtosis, all those things. Also, we talked about detail. Again, another auto EDA tool. And we saw how we can explore auto EDA. Right. We can explore detail. Everything is given here. So today we will talk about deployment. So when you talk about deployment, here, two things we use here, two libraries we use. That is joblib and pickle. The first thing we use is joblib, and of course pickle we use. So let's start with importing joblib. Let me just take more cells. Just a minute, team. Yeah. So we need to import pickle first. We need to import pickle. It's important. And we need to import joblib. We import it. Now, the question that arises is, what are these joblib and what is joblib and what is pickle? Now, both joblib and pickle are Python libraries used for serializing and deserializing objects. What we do here is to save something, to save an object, we need to deserialize it. And after that, once we try to load that, we serialize it. So serializing and deserializing means converting a Python object into a byte stream. That is serialization, and converting a byte stream back into Python object, that is deserialization. Right. Now, what is the difference? If we say that is a difference, what about the different use cases and characteristic? If we talk about pickle, pickle is again general purpose, of course. So pickle is basically designed to serialize and deserialize almost any Python object. Almost any Python object. So pickle is very much important. Well, it is a standard library. So installation is not at all needed. Also, it is single-threaded. What is single-threaded? Well, pickle works well with serializing smaller objects and for single-threaded applications. Talking about speed, for smaller object, pickle is faster than joblib. When it comes to smaller object, pickle is faster than joblib. Also, talking about file size. So, the serialized file we have in pickle is larger compared to joblib. And specifically, that is an option for NumPy array. For NumPy array, it is specifically large. If that's the case for pickle, what about joblib, you may ask? So joblib is particularly optimized for handling large data and objects. This is for smaller data, and it can be handled well handled in a really good way. Joblib is for large data and objects. Now, of course, pickle does not require to pip, whereas joblib, in joblib, when you need to install joblib, you need to pip it. When you need to pip install joblib, from where? From PyPI. So, talking about efficiency, again, we have discussed this. Joblib is more efficient than pickle for large object in terms of both speed and memory usage. We saw that, right? Pickle requires more memory to save an object, whereas joblib requires less memory. And of course, it uses efficient storage format and compresses the data. What's the format, you may ask? Well, it can store that in NumPy array. Now, talking about parallel processing, joblib prefers or supports parallel processing, whereas pickle doesn't support parallel processing. So making it useful for application that can benefit from multi-threading or parallel execution. Joblib is really very important in that case. Now, talking about memory mapping. So joblib supports memory mapping Why do we need to do memory mapping? Just to manage memory usage effectively. Again, we know joblib is good for big files, right? Large files. So that's the reason memory mapping is very important. Now the basic question that goes is when to use joblib and when to use pickle, right? This is very much important to understand when to use pickle or when to use joblib. Now we want to use pickle if we need quick and easy way to serialize a wide range of Python objects. Almost any object, as we saw, can be serialized using pickle. And if the object is relatively small, then of course we can go for pickle. But what if we have bigger object? If we are working with a large data structure or a bigger object like NumPy array, we need more efficient storage and faster serialization or deserialization. In that case, we go for joblib. Or, for example, if you want to use parallel processing power, we can go for joblib. So, if we talk about both pickle and joblib, what they do is serialize Python object. Joblib is suitable for large data and application, whereas pickle is suitable for small applications. Right. Now, after this, once we do this, let's start making models. We imported both of them. And before this, we talked about tuned result, we talked about auto ADA, we imported those files. Now, first of all, what we need to do, we need to understand that everything is given here. We got model accuracy, precision, recall, F1 score. And given that F1 score balances both precision and recall, we all know, right? So let me just write it so that you understand that. Given that the F1 score balances both precision, recall, and okay, we'll write it in the next line. Recall. Okay, we'll continue with this rather than that. And the random forest. Okay. So then it would be very long. And the random forest as the highest F1 score, accuracy, and relatively I recall. We will say that the tuned random forest model is likely the best choice. The best choice. These models. So, what will we do here? We will actually here we will use pickle.dump. We say pickle.dump, and when we are dumping something, when we are dumping the model, We're actually saying the model pickle.dump. We say the name of the model. It was best random forest. Best random forest. We say open. Of course, we are writing it. Receiving it the name of random forest pickle. Pickle. And we are saying WB. WB, when we say it's right binary, right? If you want saving a model, for example, or doing anything like that, we write WB. If you are reading a model, we write RB, read binary. Also, okay, let me just run this first. Didn't I? Okay. Oh, so sorry, my mistake. It's pickle. Okay. This model is saved. Now we say, just let's load it again. Random underscore forest equal to pickle dot load. We say open. Oh, so sorry. What's the name? Random forest pickle, right? Oh, see. So that would be random forest pickle file dot pkl, and then we say comma rb. RB is read binary, and we say, just run this line, of course. We say y underscore predicted equal to random forest dot predict bracket x underscore test data, and of course run this. Okay, again, mistake. So we want to see what is y underscore predicted. Then we get this as an array of pipeline. Now, before this, let us understand that we have not saved this till now. Till now, we have not saved anything like that. So what we need to do first of all, we need to save our previous models. For example, here, when we are doing categorical, when we are making categorical pipeline, we are not stored preprocessor here, right? Now, if you are not stored preprocessor, that would be a problem. We want to use that. We want to see how to make a proper pipeline. Now, also, Winsorizer, we need to save. So what we need to do now, here, what we will do, first of all, we'll make the pipeline. First of all, to make the pipeline, we'll save the Winsorizer model. Of course, we should have saved it then. But what is important is to explain you each and every step, or you'll forget that. Save the Winsorizer model, right? And how do we save that? Of course, we use joblib. public dot dump outlier. Just see outlier. Is it the name outlier or not? As far as I remember, the name was outlier. Yes, it's outlier. Outlier dot Windsor. We will save this model. So Windsor is saved. Now we want to save a pre-processing step. Here we have this pre-processing step, right? Of course, random forest model we saved. This pre-processing is something that we need to save. We need to save this preprocessor. What do we have in this preprocessor? We have categorical pipeline, right? We have numerical pipeline. Here. Num and cat we have named it. So what will we do here? We will say, okay, line number 57 it is. We have seen that we have transformed or not. Just submit. Yeah, we have fit and transformed X test. Okay. So now, of course, we need to save the pickle.dump. So we'll say pickle.dump. Again, we are saving preprocessing, of course. Let me just see if the name is preprocessing. It's X-train actually. To do dot fit and dot transform. Okay, no issues. We'll just see, we'll just check. If not, we'll improve. Okay, I guess there's a mistake here. What we can do is going for this. We will say, okay, we'll need to run this again, I guess. Go transform. Okay, there must be some error. Let it be. No issues. We'll continue with this. We say processing. Okay. Rather than that, why don't we just save it in another way? We say, okay, this thing the processor dot fit, and when we have dot fit, we say x underscore train, and then we say, okay, If that's the case, let's just dump it then. Pickle dot dump in bracket processing, open. We will name it as preprocessing pkl, and of course write it as right binary. So we'll do one more thing here. What we'll do is, once we make this, we'll do one thing, that we'll write a code and then we'll continue with the same, right? So what do we need to do here now is we need to load all the saved model, right? We need to load all the saved model here. Before this, need to make the pipeline first. Okay, so let us make the pipeline, or we already made it, right? We need to test it. Let us test the pipeline. So for that, we say data test data to test in deployment. First of all, what we need to do is to generate a text data to test in deployment. So, of course, we need to mention the number of rows to sample, number of rows to sample. So we give n equal to 25. We want 25 number of rows. And yes, in that case, we will select random rows. So we say random underscore sample equal to data, or I should say name is df, right? Saved with the name df, I guess. Yes, df equal to df dot drop, and we say df dot drop. Of course, what do we need to drop? We need to drop income in the column income, and we say x is equal to 1. X is equal to 1. And when we are saying x is equal to 1, we're talking about the column. Rows is basically x is equal to 0. And we say dot sample, and we say n equal to n, number of rows, comma, we say random state equal to 42. Now, what is random state? What we do here is, first of all, if we don't want our data to change again and again, if you want the same set of data that we're generating for the very first time, so that we want to test on that data that we make again and again, we use random state, right? So that once we have a sample, right? We make this sample. we don't get different set of data. We will be getting same set of data each and every time. Okay, it's already 16, so I won't continue further. I won't disturb your schedule. So we'll do one thing. From here, we'll continue further. I hope you understood the difference between import and job lib. And today, what we did, we took, we saved the random forest model since it's having the best F1 score, accuracy, and recall. Right. After that, we saved a Winsorizer, right? The Winsorizer model, and we saved the preprocessor, basically preprocessing step. And now we were testing the pipeline. We are generating a text data to test in deployment. So till this part, we are done, and we'll continue in the next video too. So thank you to so much, team. Thank you so much for your time. We'll make sure that we meet on Tuesday